it says a 1.112 gram sample of gas occupies 225 milliliters at 0.813 atmospheres and 22 degrees C. What is the molar mass of the gas? So at first sight, this seems like impossible, right? They're giving you a mass of the sample and some gas law information, and they're asking you for the molar mass of the gas. How are you going to figure that out? Normally, if you want to find a molar mass, you get a periodic table and you add up the atoms in the compound and you determine its molar mass. That being said, you can do this a little bit differently. The molar mass, mathematically, is equal to the grams divided by the moles, because molar mass is grams per mole. Well, grams are easy. We know how many grams we have. How could we find how many moles of this gas we have? Well, it turns out we have information about this gas that we can use the ideal gas law to determine the number of moles. So if you haven't watched the previous questions about the ideal gas law, you might want to start with those. The ideal gas law is PV equals nRT. In this case, we want to solve for n. So n equals PV divided by RT. So I just divided both sides by RT, just like in the previous question. Now, I want to plug in my values. The pressure is already given in atmospheres, 0.813 atmospheres. The volume is given in milliliters, so I need to divide that by 1,000. Don't plug in 225, divide it by 1,000, plug in 0.225 liters. The R is a constant, 0.08206. That's liter atmospheres per mole K, even though I'm not going to write it every time, times the temperature in Kelvin. So don't put in 22, add 273 to that, and you end up with 295 Kelvin. And when you do all this work, you find that the number of moles of this gas is not very many, 0.00756 moles of gas. Now you can determine the molar mass. You have grams, you have moles. So if you take the grams, which is 1.112 grams, which is just given in the problem, and you divide it by the moles that you just found, 0.00756 moles, you find that the molar mass of this particular gas to 3 sig figs is 147 grams per mole. So this can be used experimentally to determine molar masses, and we'll do a similar thing in a lab to determine the molar mass using a similar method.